Alrighty, now let's transition entirely into polars. And polars are written in terms of r equals. We no longer have x with respect to theta and y with respect to theta. We now have r with respect to theta. And of course, r is the radius, theta is the angle. So a polar coordinate of the form r theta tells us where to go on the unit circle in terms of theta, and then r is the number of steps we take away from the origin. So if we graph the equation 2 plus 2 cosine theta by hand, it's doable. We just plug in, say, theta equals 0, we're going to get out a 4 right here. If theta equals, say, pi over 6, we're going to get a 2 plus rad 3, which is kind of harder to tell what that's going to be. But let's see, pi over 6 is here, pi over 4 is here, pi over 3 is here, pi over 2 is here. So 2 plus the square root of 3 is going to be about here. Then if I plug in pi over 4, I get 2 rad 2 over 2. So I have 2 plus rad 2, which will be about 3.4, which might be about right here. Pi over 3, cosine of pi over 3 is 1/2, so now I'm at 3, so that's right here. Cosine of pi over 2 is 0, so that just gives me to 0 here. And I could keep going around. I won't bore you with this, but it basically is going to be a cardioid. It has symmetry with respect to the polar axis, and it looks like a sideways heart. And the way to graph that by hand is just plugging in all of the core values from the unit circle. You could also do this on your calculator. This is where your mode would move away from function mode, but go directly to polar mode. And polar mode has an R here. When you look at the polar, it'll say R equals, and you actually have to use theta as your input value. And theta is going to be at green diamond caret symbol on the TI-89. So this is a cardioid. The good news is you do not have to know how to graph polars by hand. They are going to either give you the graph or give you the graphing calculator. Now, if they ask you to find the slope at pi over 6, we're going to have a negative slope right there. That means we need dy dx where theta equals pi over 6. Well, we don't have any x's or y's. We have r equals 2 plus 2 cosine theta. So we have to go to x equals r cosine theta and y equals r cosine theta that I mentioned on the first video in this lesson. These are the standard equations to convert from polars to rectangulars. So in our case, we have r, so x equals 2 plus 2 cosine theta times cosine theta, y equals 2 plus 2 cosine theta times sine theta. So I now have x and y. Now what I have to do is differentiate each of those, and I have to get dx d theta, and I have to get dy d theta, d theta. And I'm going to do both of those using the product rule, which isn't pretty, but I'm going to do it. So 2 plus 2 cosine theta goes to negative 2 sine theta cosine theta plus 2 plus 2 cosine theta times negative sine theta. Then for dy d theta, I'm going to differentiate 2 plus 2 cosine theta to negative 2 sine theta times sine theta plus 2 plus 2 cosine theta times cosine theta. All right, that is a lot of information that we just differentiated there. So now, of course, to get dy dx, I have to take dy d theta and divide by dx d theta. So dy d theta, I'm not even going to multiply this out because I just don't care to. I know that's negative 2 sine squared theta plus 2 plus 2 cosine theta times cosine theta all over dx dt, which is negative 2 sine theta cosine theta, oh my goodness, cosine theta, close paren, plus 2 plus 2 cosine theta sine theta. This is driving me crazy, this pen right now. Okay, and you know what you're going to do is you're going to use your calculator to evaluate this at pi over 6. Aren't you excited about doing it on your calculator? And when you do it, you better find out that dy dx is equal to, drumroll, -1. Now, next problem, and the last one on this video, says, what value of theta is the tangent line to the curve horizontal? We have a horizontal tangent line whenever the numerator is equal to 0. In that case, the numerator is dy d theta. So we need to take dy d theta, which was -2 sine squared theta, plus, and then 2 plus 2 cosine theta all times cosine theta. We need that to be equal to 0. So in our calculators, actually, let's see if we need to use our calculators here. We might be able to figure it out to do without. So let's see if I can go -2 sine squared theta plus 2 cosine theta plus 2 sine squared theta equals, 2 cosine squared theta equals 0. And I think there is a double angle formula in here. 2 cosine squared theta minus 2 sine squared theta is going to get us a double angle formula. I actually don't feel like using it, so I am going to do this in my calculator. Remember though, if you're using trig and setting it equal to 0, you don't want to use the home solver screen. You want to just use the graph. And if you use the graph, you want to put this on 0 to 2 pi, and you're going to find out that theta equals 3 values, pi over 3, pi, and 5 pi over 3. The problem is, if we plugged pi in and went up to our denominator, we would have, let's see, sine of pi is 0 here and sine of pi is 0 here. So I would get a 0 denominator. So pi is not an option. My only two solutions are pi over 3 and 5 pi over 3.